This video, we're going to talk about the cotangent function and graphing cotangent functions. So let's look at the parent graph for cotangent. It's a decreasing function with asymptotes at 0 and pi. Its period is pi. It looks a whole lot like tangent, but it's decreasing instead of increasing. And where the zeros of tangent had been are the vertical asymptotes. And where the vertical asymptotes of tangent had been are the zeros because they're reciprocals of one another. So go ahead and take a look at that. They are related because they're cofunctions as well. So anything that is a tangent graph can be written as a cotangent graph and vice versa using your cofunction identities. All right, let's go ahead and take a look now at some of these graphs. So the first thing that we're going to do is we're going to put a negative in front of the cotangent graph, and we're going to see that it looks a whole lot more like the tangent graph now, but it's been shifted pi over to units, again, because they're cofunctions. That's why it does that. All right, now let's go ahead and look at negative cotangent of pi x, and we're going to see that there's going to be a horizontal compression here, and that the x-intercepts, instead of being at pi over 2 and so on, are now going to be at 1/2, 3/2, 5/2, odd multiples of 1/2. We have all those x-intercepts now instead of odd multiples of pi over 2. And the asymptotes are now at 0, 1, 2, and so on, halfway in between these x-intercepts. Now let's try to replace this pi with a 2. And you see that there's still a horizontal compression, but we're back to having zeros at odd multiples of pi over 4 now, instead of pi over 2. That period has been cut in half, and so our asymptotes now happen at 0, pi over 2, pi, 3 pi over 2, and so on. Every multiple of pi over 2, there's an asymptote. Let's make this a -3 cotangent of 4x. And I'm going to have to zoom in here a little bit since the period has decreased so much. It's decreased by a factor of 4. So instead of a period of pi, it's a period of pi over 4. My asymptote is at 0. My 0 is at pi over 8. And there's another 0 at 3 pi over 8. So every pi over 2 here, and then 0, I believe. Yep. And then no, pi over 2 is over here, so pi over 4, right? And then so every pi over 4, there's an asymptote. So 0, pi over 4, pi over 2, 3 pi over 4, pi, and so on. There's an asymptote every pi over 4 units. It was multiplied by a -3, so these points here happen to grow a lot faster, instead of this point being at what would that have been? At -1. Now it's at +3 up there. So There it is. All right, let's look now, instead of a number greater than 1, let's look at a number between 0 and 1 here for our A. And let's make this a horizontal shift of x minus pi over 4, where we have a little bit of a phase shift now. It's back to the regular shape of the cotangent graph where it's decreasing. That's good. And we see that our asymptotes and zeros have been shifted pi over 4 units to the right. And we also see that this point that normally would have been at 1 is now at 1/3. It's right about there, pi over 2. So, and then again at 3 pi over 2 and 5 pi over 2 and so on, that there's those characteristic points that are going to take on the value of A. All right, let's look at another negative cotangent graph of x minus pi over 4. So this is going to be an increasing function instead of a decreasing function. It has the same phase shift of pi over 4. Now we see the zeros are in the same place. The y values are going in the opposite direction. So where I had at pi over 2 was a positive value before, now it's a negative value of -1 at negative pi over 2, 3 pi over 2, and so on. All these odd multiples of pi over 2 have my minimum. So there you go. Not my minimum, my my A value. I said that wrong. All right, that's it for my cotangent values here, and the graphs of cotangent functions that we've graphed with transformations. Come back next time and we will talk about the graph of secant and look at some transformations of that.